Good afternoon, everyone, and welcome to NASA's Kennedy Space Center in Florida, where we're gathered today for the Orbital ATK CRS-4 pre-launch news conference. And we're very excited because it marks the resumption of cargo services from U.S. soil to the International Space Station. I'm very pleased today to be joined by Kirk Shireman, International Space Station Program Manager from NASA's Johnson Space Center in Houston, Frank Culbertson, President, Space Systems Group for Orbital ATK, Fern Thorpe, Program Manager for NASA Missions from United Launch Alliance, and Todd McNamara, Launch Weather Officer from the 45th Weather Squadron. We will begin with opening statements, and then we'll be happy to take questions from you. So we'll start off with Kirk.
All right. Good afternoon. Thank you very much. It's a pleasure to be here. I'm really excited about being here for the launch and all the great things that are to come. I wanted to give you a few words just about the status of the ISS and the ISS readiness for this operation and really what it means to us. We have our readiness review. This is the readiness of the ISS to support this mission. We had that on November 9th, and it was successful. In addition, we had a flight readiness review. That was on November 16th, and again, everything was confirmed ready to go from an ISS standpoint. So we're very pleased with that. As you probably know, this is actually the beginning of an extremely busy time on board the International Space Station. Just to give you an idea, of course, we have the launch tomorrow night. The birthing. The earliest possible birthing date is the 6th. That's what we plan. Of course, depending upon when it goes in the window, it might be the 7th, but the 6th. On the 11th of December, we have 43 Soyuz landing. On the 15th of December, we have 45 Soyuz launch and docking. On the 18th of December, 60 Progress is returning, undocking and returning. On the 21st of December, we have 62 Progress, which is launching, and it actually docks a couple days later on the 23rd. And then mercifully, we have a beta cutout, which all vehicle traffic stops. So I don't really know how we manage that, but from the December 21st or 24th through January 2nd, you won't be seeing any visiting vehicle traffic or spacewalks. It'll be a time really to catch our breath. So as you can see, extremely busy, and we won't talk about the next year. We'll have another opportunity here in the not too distant future to talk about activities after the first of the year. The robotic arm, Canadarm2 SSRMS, is ready to go. The crew is ready and trained. Kjell Lindgren is going to be our prime operator, and he will grapple Cygnus when it comes up. Scott Kelly will be his backup and support that operation. This is really interesting, and I think you'll see some visual of this in a minute. But Cygnus is going to come up to the Node 1 Nadir port, and this is the first berthing to Node 1 Nadir in quite some years. So we've just relocated the pressurized module, the PMM, and we've restored the power and to that particular port, and it's ready to support this Cygnus flight, and so we're looking forward to having it on this on Node 1 Nadir port. Another important thing from our standpoint is we're actually going to be controlling, the crew on board will be controlling the monitoring and controlling the Cygnus via their laptop computer that controls the ISS, the PCS. Previously, we've used a HTV control panel, which is the same one we used for Cygnus, but we used for the HTV vehicles. It has a cable that drags through 4 separate hatches, which poses a risk while it's there. You can't close the hatch. It takes extra time should we have an emergency and need to close the hatch. So this time we've eliminated that drag through, and we'll actually be commanding via these laptop computers that don't have any drag through. So we're looking forward to that operation. And so, like I said, the vehicle, ISS on-orbit vehicle, is ready to go and ready to support. Consumables, of course, Cygnus is bringing up a tremendous amount of cargo. In fact, the most cargo ever brought up on a Cygnus vehicle, so we're looking forward to that. Some of the consumables, as you know, 2015 has been a difficult year for ISS, but we're still in good shape with consumables. We have basically toilet supplies through February of next year, and food. We hit our our warning line, if you will, in February 19th, and right now our projections would be out of food on April 12th. So we are looking forward to having those supplies replenished on board Cygnus. Another interesting piece of cargo from a system standpoint is a nitrogen-oxygen recharge system tanks. So we're actually bringing up these high-pressure tanks that allow us to recharge the big tanks on ISS. This will be the first time we've had the opportunity to recharge those tanks since the shuttle stopped flying, because up until the NORS, the only way to recharge them was through shuttle. Let's see. The most important cargo on Cygnus is the utilization, and I think you just had a briefing on a lot of the payloads that are coming up on Cygnus, and so I won't talk too much more about that. But we really are looking forward to getting up a couple more facilities and numerous research investigations, new research investigations up there. We have a total of 324 investigations we've done during this increment pair, and it's really important that we get this cargo up there and continue our utilization activities. And then finally, I just can't emphasize enough how it's important to us on board ISS to have a regular cadence of resupply flights, and we're so much looking forward to having Cygnus back on and kind of starting a new era in ISS and back to regular resupply flights. That way we can utilize ISS like it was intended. So with that, let me pass the baton over to Frank, and he'll tell you a little bit more about Cygnus.
Thank you very much, Kirk, and thanks for the handover. And by the way, no pressure, right? I didn't know the toilet supplies were so low.
Well, you've been there. You know how it is.
Yes, I do. When I was there, all it was Node 1. So, but we are very proud to be back in this position of getting ready to launch supplies to the International Space Station again. On behalf of David Thompson and the rest of the company, I want to express our excitement in being involved in this and continuing human presence in space and research on board the space station. We have over 3,500 kilograms of cargo that we're taking up on this mission, over a third of which is for utilization and experiments, and of course that's the main mission of the ISS. But the rest of it are the things that Kurt mentioned that the crew needs to continue to survive and to continue their presence on the station. And we see them as our ultimate customer, so we want to take them what they need. I'm guessing the Santa's sleigh is somewhere inside the Cygnus, and they're probably excited about their stockings coming up too. This spacecraft is named the Deke Slayton II. It's the same name as the Orb-4 mission was going to be originally, and so we thought it was important that we continue that mission and get Deke into space so that we can honor his legacy and his name. We've already taken over 3,600 kilograms of cargo to the space station, removed over 3,100 kilograms, and we're looking forward to continuing to do that for the foreseeable future. It's been a challenge to get back to this point after our mishap at Wallops, but return to flight became the company's very, very sharp focus after that, and within a few days, actually, we had a plan. And with the help of our friends at ULA, who stepped forward and offered us a ride in a very short period of time, we've reached this point, and we're very excited about it. It was less than 12 months from the time we started talking about this till we got to the point where we are ready to go. That's quite an accomplishment for commercial space industry, in my opinion, and I think it says a lot about what we can do to support NASA and all of exploration in space. I do have a couple of short videos I'd like to show. The first one, if we can go ahead and roll that, shows processing of the Cygnus beginning at our facility in Dulles, where the service module was assembled and tested. These are our new solar arrays that come also from Orbital ATK. Our Goleta facility builds these. It's a new solar array that's lighter and more powerful, and we think will be utilized by a lot of spacecraft in the future. We shipped the service module down here to Kennedy Space Center, where it came to the space station processing facility to be mated with the pressurized cargo module that had arrived earlier. And you can see we put it in the vertical in order to mate the two vehicles. Prior to that, we loaded the initial load of cargo on board the Deke Slayton and packed it as tightly as we could, left some room for late load, and which we accomplished a couple of weeks ago. The process has gone very smoothly. It's great to be down here at the Cape working with the people who know how to manage space hardware and how to process it and to get it ready for flight. Once we had put the two parts of the vehicle together, it was taken over to the Cape side and integrated with the upper stage of the Atlas, encapsulated in the fairing after we did the final load of cargo, which you see going on here. The processing both at KSC and at the ULA facility has been superb. The team has worked really well together, and it's quite impressive to see what they're willing to do to keep this program going. And we certainly appreciate the people leaning forward and working so hard to make this happen. We did manage to accompany the vehicle out to the pad this morning. That was quite a sight, too, to see the Atlas roll out and zip its way along the causeway there to the track to the launch site at a couple of miles an hour, and it's pretty impressive sitting out there on the pad. We're really looking forward to the launch tomorrow afternoon. I have one other short video I'd like to show, which describes what Kurt was talking about, the berthing process. When we approach the station, we are basically in autonomous control, though we do have checks and balances, both from our control center and from the crew, that can abort the mission if necessary if something's not right. But if it all goes well, we'll stop about 10 meters below the station. Below Node 2, the crew will grapple us, Joe will grapple us with the Canadian arm, and then move it over beneath Node 1, where it will be berthed for the first time for a Cygnus vehicle. This required some modification of procedures and software and the operations, but we are optimistic this will go very well and give the crew the flexibility to have actually two cargo vehicles berthed to the station at the same time. Once they've emptied it and loaded it with cargo, and we could continue to roll this a little bit, I'll show you the unberthing, and you can see that there's another unnamed cargo vehicle on Node 2 that's planned to be there. We'll stay away from that, and we'll depart with our load of disposal cargo before they're ready to go, if all goes per NASA's current plan. We'll deorbit a couple of days later. Everything will burn up, we hope, and land in the Pacific somewhere. Okay, we can stop that now. So, as I said, we're very proud to be down here and demonstrating the flexibility of being able to launch from two different sites. Our next mission after this one is planned for early next spring, also on an Atlas. It'll be virtually identical to OA-4. It'll be named OA-6. And that's my fault, but we didn't want to change it after it was set in stone. And then the next one, OA-5, will go out of Wallops on an Antares rocket. We are currently finishing up the integration of the first ship set of engines with the core, and we'll roll it out to the pad in early spring to do a hot fire, and then roll the first flight out to the pad in late spring for a launch on the date that NASA asks us to. So we'll fly three missions in less than 6 months per the current plan. I look forward to your questions, and I know you probably have some, and I'll pass it over to Vern at this time. And Vern, thank you very much for all your team has done to get us to this point.
Okay,
looking forward to a great ride.
Thanks, Frank. Appreciate that. So I'd like to say that United Launch Alliance is honored to be here today, one day before the launch of the OA-4 Cygnus cargo mission. This will be ULA's first ISS cargo mission, and we're very excited and proud to support this critical mission, providing supplies, experiments, and other equipment for the ISS crew. It was actually 1 year ago today that I first met the engineering and the management team from Orbital ATK that we would be working with on this mission. That was the same week that we launched the EFT mission for NASA. And during that week, we met with some of the Orbital folks down here. We gave them a tour of our facilities, and that was all in preparation for formally kicking off the actual integration activity. We actually kicked off the formal mission integration work on December 9th of last year, so a week from next Tuesday, which means, as Frank said, it took us less than a year to go from integration to launch for this mission. When we first started working with Orbital ATK and the NASA Johnson folks as well, it was obvious from the start that all the parties involved with this mission had a tremendous amount of practical operational experience that they brought to the table. And as a result, the technical integration activity has gone very smoothly, and it's been an absolute pleasure working with both Orbital ATK and the NASA folks on this program. While I'm at it, I would also like to thank the U.S. Air Force, the local 45th Space Wing folks. They view us as their customer for this mission, and as usual, they've provided an outstanding level of service and helped us get to this point. And I'd also like to thank the FAA as well. This is one of the first launches for which ULA had to get an FAA license to launch. The first one was actually EFT-1 about a year ago. And we've worked very closely with the FAA to ensure that all of our processes meet their requirements and that we're compliant with everything. And they've been with us every step of the way as we've prepared for this launch. As always, it's taken a tremendous team effort to get to this point, and we look forward to a great launch tomorrow evening. I can give you a few facts and figures about the vehicle that we're using. OA-4 will be ULA's 12th and final launch of 2015. This will also be the 103rd launch that ULA has performed since ULA formed in December of 2006. In fact, yesterday was ULA's 9th anniversary. This will also be the 60th Atlas V rocket that has launched, and we will be using the Atlas 401 configuration that many of you are familiar with. We're going to use our longest of our three 4-meter payload-carrying lengths for this mission. We won't have any solid rocket boosters. In fact, the model in front of me is the configuration that we'll be flying tomorrow. And we started building the actual hardware for this vehicle about 2 years ago in our Decatur, Alabama plant. And I would now like to show a video that will give you a preview of what we're going to see tomorrow evening. Can we cue that up?
The following profile details the important events of this mission using approximate times.
5, 4, 3. We have Atlas ignition. 2, 1, 0, and liftoff. We have liftoff of the Atlas V rocket carrying.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 83 seconds. At 94 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas V is burning propellant at the rate of 1,350 pounds per second, traveling at approximately 10,000 miles per hour, and located 79 miles in altitude and 172 miles downrange. Booster engine cutoff occurs 4 minutes and 15 seconds after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4 minutes and 40 seconds into the flight. Cutoff of the Centaur main engine follows a nearly 14-minute burn. The mission now enters a short coast in preparation for spacecraft separation. At just over 21 minutes, Centaur releases the Cygnus spacecraft for Orbital ATK and NASA.
Hey, thanks. So you may have noticed that this is a very short flight profile compared to what we usually fly. We'll be separating the Cygnus module into its required orbit 21 minutes after T0. So if you order a pizza right at T0, we're probably going to have the module in orbit before the pizza arrives. Depends how, that doesn't count if you're right next door to the pizza shop. After we separate Cygnus, you might be interested to know that we are going to do a second burn. That second burn will occur about 48 minutes after liftoff. It will last for 11 seconds. It will occur over the Indian Ocean, and it will allow us to execute a controlled re-entry of the Centaur upper stage. And we're predicting, under nominal conditions, anything that survives re-entry will impact in the ocean south of Australia in a predetermined area about an hour and 9 minutes after liftoff. After we launch OA-4, as I mentioned before, we're done for the year, but we have a very busy manifest planned for 2016. We actually have 16 launches planned next year. 12 of those will be from the Cape here in Florida, and one of those will be the OA-6 mission for Orbital, again, somewhat of a duplicate of this mission in March of next year. And as always, it's an honor to deliver these missions for both our government and our commercial customers. I'd like to say thanks again to all of the partners who we work with to help get us here. We're going to continue at ULA to focus relentlessly on mission success as we deliver our nation's most important payloads and critical capabilities to orbit. And we're all looking forward to a great launch tomorrow evening, and we hope the weather cooperates. And I will pass it over to Todd so he can tell us about that.
Thanks, Vern. Good afternoon, everyone. So far, the weather is looking pretty favorable. Right now, we're at a 40% chance of violating launch weather constraints. We've kind of maintained that throughout the last 3 or 4 days in the forecast. And it would have been nice if we could have done this a little earlier. We've had pretty favorable weather the last basically week, but we're going to see a little change. If we take a look at the satellite right now, you can see on the satellite loop we do have an ominous weather front kind of coming our way. It's brought a lot of snow, windy conditions, freezing rain throughout the Great Plains and now moving into the Ohio Valley region. And that frontal boundary extends right now through that Ohio Valley region down through the eastern part of Texas. For the last few days, as I mentioned, and even through today, we've had pretty good conditions here. No weather effects towards rollout to the pad. But as we go through the night, we're actually going to see that frontal boundary kind of move our way. So we've started out with pretty good weather conditions. We're going to see decreasing or deteriorating weather conditions throughout the night. The front itself will pass through us somewhere in the early morning hours, right before sunrise. And as it does, we'll start to see clouds continue to increase throughout the day and through the evening, and we'll see showers kind of move through the area. The good news is, once this frontal boundary pushes through us in the early morning hours, we're expecting it to continue to move to the south. So by the time we get to the launch time, the frontal boundary should be down to the south, maybe around the Lake Okeechobee region. So we'll be looking at some residual cloudiness around the area, maybe some light rain showers with that cloudiness. And as a result of those clouds and showers around, we're looking at 3 weather rules: the disturbed weather rule, the cumulus cloud rule, and the thick cloud rule to be our main weather concerns. So especially with the thick cloud rule, with those clouds kind of lingering around, we'll be watching for clouds between roughly 13,000 feet and 25,000 feet in the atmosphere. So that'll be our main concern. And as I mentioned, right now we're at a 40% chance of violating those launch constraints. If we do slip into Friday, we'll see that frontal boundary kind of stay down in southern Florida. Well, we will have an upper level disturbance kind of move over the top of it, and that's going to move some of that cloudiness back in over the top of us, and we'll see some increase in showers possibly on Friday. So we're going to increase our probability of violating weather constraints to 60% on Friday, and still due to the cumulus cloud rule, the thick cloud rule, and the disturbed weather rule. On Friday, we will see our winds start to pick up. I think we'll see 18 to 22 knot peak winds out at the pad tomorrow at 230 feet for launch, and then maybe a few knots more on Friday as we get a little bit stronger winds with that northerly flow back behind the frontal boundary itself. So overall, we're looking at fairly favorable conditions. It's going to look pretty bad as we get into the evening time and the early morning time as that front comes through and we have those showers. But we're pretty sure that most of the thunderstorm activity will be well up to the north. We're not expecting any thunderstorms in the area, maybe just some of those showers and lingering clouds as we get into the afternoon time tomorrow. So overall, a probability of violating weather constraints is at 40%. And that's all I have for weather, Mike.
Okay, Todd, thank you. All right, we'll take questions. Please remember to wait for the microphone and state your name and affiliation, and it will really help if you will address your question to the appropriate person. We'll start off with Marcia Dunn.
Marcia Dunn, Associated Press. First for Frank. How many days can you try, and could you just launch and hang around in orbit waiting for the Russian traffic to go, or is that not in your plan? And for Kirk, your April threshold for food, will the progress coming up later this month bump that, help you there?
Basically, we've got about 3 days in which we could launch and then go to the station on a 2, 3, or 4 day timeline. But it's really between ULA and ourselves as to how long we keep trying and when we keep going. Theoretically, even if we launched after the optimum time for rendezvousing with the station, we could loiter for quite a while in orbit until they opened up a window for us to approach the station. And we've discussed that with NASA. We're ready to have that discussion if necessary, but it looks pretty good for tomorrow, so we think we'll go.
And relative to 62 Progress, yes, it is bringing up some food. I have the numbers. I just don't have them with me. So if you'd like, after we get done, I'd be happy to look it up real quick. I can put my hands on it. It will a little bit, yes, absolutely. There are other methods of getting food up there that we plan on carrying some food. We typically carry a few days worth of food on the Soyuz. Of course, we have 62 Progress, and we're planning on a Dragon flight early next year as well. So there are other methods. It's not a critical situation. I was just giving you an idea that we're not where we really like to be relative to our consumables, but we're not in a critical situation at all.
Bill.
Bill Harwood, CBS, with two questions for Kirk. One is, where are you now, percentages-wise, with consumables, given where you were before the Orb-3 failure last year, and then the two subsequent failures? When will you get back to that pre-mishap level of consumables, number one? And then I have a follow-up.
Okay, so the way I look at it, Bill, is we had 5 cargo supply chains a little over a year ago, and 4 of those supply chains were disrupted this year. So ATV, we flew the last ATV and it's gone. We aren't flying any more ATVs. We had the Orbital accident. We had a SpaceX Dragon accident. We had a Progress accident. So quite a disruption in our supply chain. We did have the consumables that people traditionally think about: food, water, toilet supplies, all those things that are required. We had more. I could give you an exact date of where they are, but the thing I really wanted to convey is that it's more than just those things. We've consumed some spares. So we put spares. We call them critical on-orbit spares for our water processor, for our solar arrays, all these things, and we've consumed those things. So there's not a crisp answer. At this date, we'll be back to where we were. During this time period, what we have done is the opportunities we have had, we put those most critical, time-critical resupplies on board. So the food and those kinds of things we put on. But we've been consuming some of our critical spares. So we are below where we would like to be relative to some of our on-orbit hardware spares. We've also prioritized our science at a much higher level. So food and science have been our number one priorities, and been consuming these spares. So I can find some data for you, but I'll tell you, it's not going to be a really crisp answer. I expect that by the end of this of next calendar year, a year from now, if we were talking and things go according to plan, we'll be back in a very robust configuration. But it'll be hard to give you a crisper answer than that.
Okay. Well, I'd still like it anyway. But
yeah.
The second question was, you got a busy January coming up too, and without bothering to ask you about when SpaceX might fly, because who knows. You guys are looking at an EVA, aren't you, to replace the sequential shunt unit on P6? And I'm wondering how that might fit into that, given the beta angle issue that comes up in January, how SpaceX might figure into that, and your priority for doing that EVA to get that power channel back. Thanks.
Very good. Yes, we have a sequential shunt unit failure, which really is actually mounted on the solar array, one of our 8 solar array wings. It's mounted on the starboard side, the right-hand side, all the way out at the very end of the truss. That we believe what has happened is that we sent about 2,000 amps. The last piece of data we had was about 2,000 amps going through that guy. We think he is done. And so it doesn't take very long for 2,000 amps to do some damage. So we don't understand exactly why it failed. We have had one previous sequential shunt unit failure on orbit. We have that actually on the ground and in repair at this point in time. We have a spare sequential shunt unit on orbit. We know exactly where it is. We're actually going to fly some cables up on Soyuz here in a little over a week and a half to test that guy out, make sure it's in a good configuration. And we actually have another spare here at the Kennedy Space Center right now. We are looking at EVA opportunities. Things are not as easy as they might seem. In order to do the spacewalk, you actually have to do it in eclipse because of the high power involved. And so you need to maximize the eclipse time, which occurs during a solar beta of 0. And if you remember what I said earlier, we were getting in a high beta time period, which basically has no eclipse around the end of the calendar year. We need to go down to a maximum eclipse, which will happen about the middle of the month. So we're looking at an opportunity in the middle. I think the 12th through the 18th is when the beta is within the window that we would be able to execute it. So we are actually talking about that as a program right now. We do have some flexibility. We really haven't lost redundancy because of the hardware, the power channelization. We can withstand another failure and still be safe on board ISS from a power standpoint. We have lost one solar array's worth of energy, so balancing or allocating power to the various loads is a little more difficult now. But it's not time critical that we do it, but we are looking at an opportunity in January. Again, balancing not only readiness of the team and the crew to perform that EVA, but also the vehicle traffic and when vehicles might be ready to arrive and or depart. So I would expect, though, that in fact, I have a review this Friday afternoon with my team on this very subject. So I expect us to make a decision here in the next week about whether or not we'll try to execute an EVA in January. We're certainly prepared to go beyond January into February or March if we need to do that spacewalk.
Let's take a question over here.
Doug Boney, TMCnet. This question's for Frank. The Cygnus-Atlas combination provides the ability to put more cargo into orbit on a launch. Do you see Cygnus and Atlas to be a potential option for NASA in the future, given that you'll potentially need to move more cargo up to station if it goes up to a 7-member crew? Is this something that you put out in CRS-2 or NASA's discussed?
We're still in the middle of that procurement, so I really can't talk about the details of that. It wouldn't be appropriate to really get into that. But obviously, flying on Atlas gives us lots of capability, and when we fly OA-5 on Antares, we'll also be carrying more cargo than we did in the past because of the increased performance. So we have two options for flying cargo to the station now.
Ken?
Ken Kramer for Universe Today and Northeast Astronomy Forum, also for Frank. I was wondering, it sounded like you're going to just have 3 launches next year. Are you going to have one Antares at all? And would you consider, sort of following up, would you consider ever launching another Cygnus on an Atlas?
Sure, we would consider that if the opportunity arose. To be clear, what I outlined were the flights through next spring, through May or June, which the third of which will be in Antares. We also have another one scheduled in the fall, also in Antares out of Wallops. So essentially, we'll have 4 flights in less than 12 months.
I'm just wondering also, you're delaying the hot fire test a month or two. Will that cause a delay in the first Antares, or are you still aiming for May, June?
No, actually, we're right on track for what we've planned. We modified the hot fire somewhat, which changed the schedule a little bit, but we're right on track for doing it in February or March, and then the launch is actually capable of flying in early May if we need to.
We'll take one more in the room here before we go to the telephone bridge.
Jim Siegel, I'm with the Celebration News and Spaceflight Insider. I have a question for Frank. Could you talk a little bit to contrast the launching here at the Cape versus at Wallops Island? What are kind of the pluses and minuses of each one, the advantages and disadvantages of each one from your point of view?
Well, I guess the differences have to do with how we process the spacecraft and the cargo in terms of both the facilities we use as well as the timeline we're able to execute on. At Wallops, we can load cargo as late as about 3 days before the flight. Because we were brought in on a fairly tight timeline with ULA, and they need to encapsulate the spacecraft about 2 weeks before launch. We had to launch or to load the final cargo about L-2 weeks, which took away some of NASA's flexibility in terms of science payloads that they could put on. We're discussing ways to shorten that timeline here with ULA. As far as the way the processing goes, other than that encapsulation, it's pretty much the same in terms of handling the hardware, handling the spacecraft, and then the Atlas has different procedures and operations than the Antares does, but it results in the same thing: cargo to the space station.
I believe Phil Keating from Fox News is on the telephone with a question. Phil, go ahead.
Hey, good afternoon, everybody. Good luck tomorrow on the big launch. The truth of rocket science is it's not always perfect, and this past 13 months of cargo ship deliveries have shown the mishaps and anomalies vividly. With that in mind, Kirk and Frank, but first to Frank, do you feel like the entire post-shuttle NASA paradigm of privatizing and outsourcing our cargo runs to the space station is really under the microscope for a big, high-stakes launch tomorrow? And how prepared do you guys feel and confident do you feel?
Well, we feel extremely confident, or we wouldn't be sitting on top of that rocket right now. We've been through a lot of reviews, both internal and with folks in NASA and elsewhere looking at us. And you're right, it is a challenging business. We're dealing with a lot of energy, a lot of power coming off the pad, and a lot of complexity in the vehicles, and that's just a part of the business. And we've learned that the hard way over the years many times. But we always come back from that, and we always do whatever is necessary to correct whatever problems occur, whether they're minor or major. So we feel very good about launching out of here and getting back to the station tomorrow. I'm well aware of the changing paradigm within NASA, having been a part of the shuttle and station programs and now a part of commercial space flight. And there are changing paradigms, but I think people, particularly the leadership of all the organizations involved, are adapting very well. And they understand the difference between a services contract, a commercial fixed-price contract, and a traditional government cost-plus contract where the government owned the hardware. And yeah, there are people who probably wish for the days of the shuttle, but there were pros and cons to that too. But the only way we're going to keep cargo and people going into space is to move towards a more cost-effective model and to let industry participate more and accept some of the risks that are inherent in this business. And I think NASA knows that, and I think some of our other government customers know that, and we're starting to move more and more in that direction. So I'm very optimistic about the future of our business.
Yeah, and my thought is, first of all, space is a risky business. There's no doubt. I think the last year has demonstrated that. And anytime you take something, it's hard to describe to people. But you take something and as large. This is a 4-meter fairing that weighs 8,000 pounds, and we're launching it to 17,500 miles an hour in the time you can get a pizza. And things are rotating at over 10,000 revolutions per minute, and everything has to work exactly as planned. The attention to detail required is really, really important. You can't have things over-designed because the mass gets so heavy you can't lift it. And I was talking while we were walking down the pad the other day, and it was amazing because you see the rocket right next to the launch pad, and they have these big attach points that hold the rocket in place. And it's amazing to me. That's a stark difference between vehicles that fly and vehicles that stay on the ground, because you see these giant actuators that are this big, and they're attached to this rocket, this little, this relatively small, tiny attach point on the rocket, and yet that's what holds it together. The difference is that attach point flies, and that big actuator doesn't. So it is a risky business, and we know that every day. Having said that, ULA, as you heard Vern talk about, it has a remarkable success record. The work that's been going on in the last year between Orbital ATK and ULA to fly, to first of all to modify the Cygnus, which was already in the plan, but then to analyze it to fly on an Atlas has been incredible. And it's been extremely clean in all our reviews, both at NASA and what I've heard from the Orbital and ULA results, an extremely clean vehicle. So I feel very comfortable about that. I agree relative to commercial space. The commercial space is going to happen. It's inevitable. It is occurring right now. It is our future. NASA needs it to happen as Frank was talking about, relative to sharing the financial risk, if you will. But the truth is, the space market is increasing, and we expect it to increase even more. It's not something that NASA or the U.S. government can own by itself. It's something that's growing organically at this point in time, and as a result, it actually has a benefit to NASA. We actually expect to get our launch costs cheaper in the future as a result of this growing commercial market. We expect to be able to fly crews safely to orbit and cheaper in the future because of commercial space. So we're in that transition period. There are certainly growing pains. There were probably more growing pains ahead of us, but it's our all responsibility to make sure that we're successful, and I'm confident that we will be.
Kirk made a point I'd like to elaborate on a little bit. He talked about attention to detail. That's a feature of our business that I think is extremely critical, and is something that you see, all of us see, across the industry, whether it's government employees, contractors, or folks who are checking what we do. And hopefully the media pays a lot of attention to accuracy and detail. Because aerospace, the industry writ large, is very unique in terms of how people approach it. We all understand how serious this business is, how difficult it is, but how important it is to the future of this country and to the rest of the world. And everybody I know who works in this business, whether they're turning a wrench on an engine, building a piece of structure, or managing research remotely on the space station, or actually flying in space, takes it very seriously and pays a lot of attention to detail and takes personal responsibility for what their jobs are. And that's one of the reasons I love this business, because you're working with people who care, and who care about what they're doing right now, and who care about the future for our children and grandchildren. So it's a great place to be right now.
Okay, front row.
Gene McCullough with Talking Space. That gantry wasn't there a few weeks ago. I guess the question is for Vern Thorpe. What are you doing is this going to be an opportunity to test the performance of that gantry? And also, that's also actually a active construction site, and there's probably FOD all over the place. What are you doing to make sure to mitigate any foreign object debris that might impact the vehicle? Thanks.
Okay, yeah, I can answer that. So that is the crew access tower that you see that has gone up this year. We're going to be using that for astronauts to actually board the capsule when we start flying a commercial crew in 2018. And the only testing, if you will, that's happening is its ability to withstand the acoustic and blast environment of launch. And analytically, I mean, it was designed to withstand that, and we know it will. In fact, it's been there for several launches already with no problems. Prior to every launch, we do cease work on the construction site a couple of days ahead of time, and between us and the contractor who's putting that up for us, there is a very thorough, very detailed review and walk down to make sure that we don't have any FOD dangers down there. So we're concerned about exactly what you mentioned, and we take great pains and spend a lot of time making sure that we won't have any issues. We make sure that everything is secured, everything is cleaned up, and the pad is pristine in advance of every one of our launches.
James.
Oh, thanks. James Dean, Florida Today. One for Kirk and one for Frank, if there's time. Sorry, Kirk. Just back on the consumables, I appreciate there's no crisis or anything right now. Hopefully everything goes perfectly tomorrow, but just wondered if you could address, in the unlikely event there is another bad day, I'm wondering how you would be postured, whether the crisis would be more urgent than it was last time, because looking ahead, I wonder if you could address when you expect SpaceX to launch next. You don't have ATV, as you mentioned. I don't know if you do have an HTV in the pipeline like you did this year that would help take the pressure off the U.S. commercial vehicles, which you're going to rely on increasingly as we move forward. So could you just sort of, if you had another setback now or later, how well would you be able to absorb that compared to how this past year played out?
I'll do my best. Of course, it depends on the specific situation and when it occurs as to how we'd react. So, but it's interesting. We had 3 accidents last year, and all 3 of those vehicles are right now planned to launch within the next 31 days. So it's really interesting that the Progress had a failure. It's the 62 Progress is about to launch. In fact, that'll be the next cargo vehicle after this. And SpaceX right now is no earlier than January 8th. Of course, there's still technical issues that because they're recovering from an accident as well. So. There's a chance that date won't hold, but we're ready to handle launch delays. That's another facet of our business. as things happen, thunderstorms come up, or technical issues with the rockets, because they have to be so pristine when we fire them. So it's certainly possible. What we would do, though, is we would first of all we always monitor where we are on relative to our consumables, and we have adequate ones. I think I mentioned that we hit our warning line, if you will, in February, and then we run out in April. So the options would be remanifest some of the vehicles that would come later. We'd put some more of those critical consumables on there. Obviously, we would look at, depending upon what the consumables are there ways to ration those? And I'm not talking about necessarily, rationing food at this point in time, but depending upon what the consumable is, there may be other options, some activities you wouldn't do just to protect those consumables. But we've been in a situation in the past where we had a disrupted supply chain in the past, and we know the knobs to turn. It just depends on the specific situation as to what we do. Again, here in the next 2 weeks we have or next 3 weeks we have. This launch, we have a Soyuz launch, which has the ability for a little cargo, and a Progress launch. So there are multiple opportunities here in the next few weeks, not to mention after the first of the year. So we're not overly concerned at this point in time, but again, we're not as robust as we would like to be.
And Frank, I was just wondering, to what extent the image of Orb-3 is on your mind today and going into tomorrow. Is that a source of sort of extra election nerves going into this launch? Although it's not your rocket, has there been any discussion with your teams about sort of putting that behind you, focusing on this and having a successful day?
We tend not to be melodramatic about those things. We're focused on this launch here, and everybody's ready to do their job. If we have to deal with a contingency, we will. But right now we're focused on the success of this mission and getting the cargo to the space station. Very optimistic.
Okay, question here in the front.
Hi there. Joey Vars from Crow's Nest and For All Mankind. My question is going to be for Vern. What sets OA-4 and EFT-1 apart from other flights that required FAA involvement?
So the other FAA licensed launches that we have performed were actually launched through Lockheed Martin Commercial Launch Services. So you're probably aware that at ULA, when we sell a launch service to a commercial end user, a typical communication satellite or direct broadcast TV satellite, those launch services are sold through Lockheed Martin Commercial Launch Services, CLS, and CLS has the responsibility for getting the license for those missions. So the difference for EFT and OA-4 is that we were responsible for getting the license, so we had to sort of relearn how to fill out all the applications. We have a lawyer who specializes in that, working with the FAA. And then we had ultimate responsibility for making sure that every single requirement was satisfied. Normally, we support CLS in doing that, and they probably took care of 50% of the work on their own. This time, we're doing it 100% on our own. So that's what's new. And then I would add to that over the years, the FAA's rules for commercial space and the requirements that you have to meet have gradually evolved as well. So since it's been a while since we've had total responsibility, there was quite a learning curve for these last two missions where we had to do it. But I think it's turned out very well.
Irene?
Irene Klotz with Reuters. I have two questions. The first for you, Kirk. Could you just kind of go through some of the implications of the power channel issue? If there was another failure at that point, do you lose redundancy, and does the whole schedule that you outlined kind of need to be reworked? Is it possible to use that kind of used spare that's on board, or what would happen?
Sure. First off, the way we think of it is we talk about the next worst failure. And so we typically have the ability to sustain one failure, and then for a period of time we can operate in a degraded mode before we can make repairs. In this particular case, and that's even more important when the devices that can fail are outside, because you can't. It takes longer to mount a spacewalk to go out and make the repairs. In this particular case, because the way the architecture of our power system, we've lost the power from that, but we haven't actually lost any redundancy. So the next worst failure is no worse today than it was before we had this sequential shunt unit. So just an artifact of our design. We planned for these kinds of failures. There's a couple of other devices that could fail and really would not degrade our redundancy. So it's again, we've reduced the overall power generation capability of our system, but we actually haven't reduced the redundancy at all. So when does power generation becomes an issue? When you actually have to hold a fixed attitude for something. So if you have to hold a particular attitude for a visiting vehicle, then you have to manage the power very, very delicately, because you're not in an optimum power generation attitude. So that's what we do. We have no issue. If we have a next worst failure, we really haven't lost any redundancy. The next worst failure would be a main bus switching unit, which could take out would take out a significant amount of redundancy, and then we'd be in a much more urgent situation to go outside and make repair either to the sequential shunt unit or the other device that failed. By the way, there's a long list of other failures that we could have that we're prepared to go do those things, but we're not in a critical situation that if the next forced failure were to occur, we have to go outside in 24 hours. We're not in that kind of a situation at all. Really, we've just made our operators earn their pay a little harder. They have to manage the power balance and what things they power off. Typically, we power off things like heaters, and if we have to, we power off fans and other things. We give first priority to the arm if it's grabbing a Cygnus vehicle, and then payloads. So and then the other things below that would be the things that we would power down for a short duration during a power intensive operation.
And I have a question for you, Frank. Regarding the Antares, two parts to it. First is, did Orbital even toy with the idea of just retiring the rocket and buying rides from ULA for the rest of the contract? No?
No.
Okay. And the other question is, outside of NASA, what are the prospects for sales of Antares?
Actually, we're talking to several potential customers, and I think they'll probably wait until we get going again before they get serious about it, but we've got some pretty good prospects for flying additional payloads on board Antares, as well as for modifying it to carry other types of missions.
Unfortunately, we have run out of time for questions, so I apologize to those of you in the room who haven't gotten your questions asked. We'll be here afterward. I'd like to close with some closing comments from Mr. Shireman. Kirk?
Sure. Again, I think we've touched on it a little bit today, but I really want to convey to you how impressed I am that Orbital and ULA have been able to create this marriage and be in this position just literally a year from when it started. These are complicated vehicles. Flying in space is difficult. We talked about that, and it really is. I've been in this business a long time, and I'm very impressed that we are at this position here, ready to go launch in a little over 24 hours. So amazing to me. The second thing we also touched on a year ago, really a year and a couple days from in a year and 2 days from ago, we were all here looking for the first flight of Orion, and which is really the stair step for exploration, and I feel like we're taking another step here tomorrow. So a lot of the research on board ISS is really leading us to exploration, and so I see this as another step in that progression towards human exploration. I see it as another step towards commercialization, and I'm really excited about the opportunity that we're going to have tomorrow. So thank you very much for your time.
All right. Thank you all very much for coming. Our launch coverage tomorrow on NASA television will begin at 4:30 p.m. Eastern Time for a launch scheduled at 5:55 p.m. Eastern. Between now and then, please keep up with any updates by going to the web, www.nasa.gov/orbitalatk. And if you have any questions, you can address them at #AskNASA. Thank you very much.